Welcome back everyone to our Geospatial Python series. Today we will learn how to compute spectral indices. And as always, let me introduce you to my file and folder structure. There is the data folder and the output folder, which are both empty. And unlike other previous tutorials, today we will all get the data together and work with it. So we will be using Sentinel-2 data from Copernicus, and then we will make some references to this documentation on indices from Sentinel Hub and Index database. All these links will be in the description below, and in case you are new, make sure you also check out the repositories link, the GitHub link in the description. On that page, this README file will show you how to set up your Python geospatial environment and be able to follow these tutorials. So let us get started. Alright, so the first thing is to get the data, and that we do from Copernicus browser. I also have QGIS opened, and we'll be using it for visualizations as well. The link will take you to this web page, and what you want to do is to click on Explore Data. You can see here that I am logged in because my name is at the top there. I recommend that if you don't have an account, you create one. It is very fast and simple, and you log in as well, because if you don't log in, you will not be able to download the data. And so I'll just zoom into the central part of the screen here in Austria somewhere, and I want a place that will both have water and vegetation. So this place looks good to me. Not so big, we just want a small place for the analysis. And I will put an area of interest here, like that. And then I will come to this search site at the left, choose Sentinel-2, the L2A, which is already corrected for bottom of atmosphere reflectance. So we can use it straight away. And I want to search for images from March to, let's just say, May. Then I'll search. So we have some results here. So what I'll do is to go through it and pick any of them which is cloud free, so I can load more. And one of the things we can also do here is to adjust the cloud cover percentage. And then I'll click on this visualize to see what is here. Okay, so I think this is good for just the teaching purposes. For your case, you have to take your time and look through and get the best images for your analysis. This is the place I want. And let me just zoom out just a bit also. If I want to download the entire tile, I will come back to search here. And what I'll do is to click on this download button. But that will be too much for our analysis. So I just want to download this extent that I see here. For that case, I will click on this icon here, it says download image. Come to the analytical tab. I will choose TIFF 32-bit float. You can choose any of the TIFFs, but I prefer the 32-bit float. I will choose a resolution of high, and I will choose the UTM zone 33 because that is the zone for this place that I am taking the image from. So for your case, make sure you pick the UTM zone for the place you are working at. I'll click this show more, and what I want to do is to select all these bands. You may not need all of them for what we will be doing, but at least it will help you understand the process better. I will leave the true color because I will visualize that one in QGIS. And so when you are done with it like that, you just have to click download and you will have it on your computer. So you can see it is done downloading. It's a small file size as compared to the entire tile. So I'll bring it into Visual Studio Code and we will continue the analysis from there. All right, so I have the image here in this folder called Browser Images, quite long names. So you can see all our bands here with a true color as well. So you can follow the same. I have now 3 folders in the Spectral Indices folder. This one, I'll delete it very soon, but for now, let it be there. When I come to QGIS, I can visualize the true color like this, and you can see this is exactly the extent we were looking at in the Copernicus browser. So we have the right image. Let me remove it from here, and let's come back to Python. Now you can see that these file names are so long, so I will want to rename them and then also move them from this current folder to the data folder, because that is the folder we'll be keeping all our data in. So let me get a code cell, and here let's make the imports. So I will import OS. I will also from glob import glob. We will be using raster for the raster operations, so we want to import raster as real by convention, and I also want to import regular expressions, and from pathlib I want to import path. For some reason I like to use that one for some path operations. I don't know why. I think this is just too large. This should be okay for your eyes. And so if I run this, hopefully I don't get any error, and that is what I'm looking for. And so this part of renaming, let me first declare some directories like I like to do. So define directories. We will have our base directory, which is path.cwd, so the current working directory. We will also have our data directory, which will be base there .join path, and this is our data directory that is already existing in the folder. So this base there will point to the directory, current working directory, which is also, in this case, the directory where this current Python file is, or IPython file is. So it's this spectral indices folder. And so when we join the path to data, it will link to this data folder here. And then we will have an output folder. I'm sure you guessed that. So output directory. That should also be base there dot join path, and we'll join the path with output. But I also, for the purpose of renaming, want to create a temporary directory, which will be base there dot join path. But this will not be temp like the name. It will be browser images, where the files are located. This part, I will delete it most likely before I put the code to GitHub, because it's just for me to do the renaming. So I'll run this and we are safe. So this part of the renaming, you don't have to do it like I'm doing. You can choose to right click on the names one by one and then rename them, but I want to do it with code. So let me paste it from my notes and explain it. So what I'm doing is using glob to get the files in the temporary directory, which is also where my Sentinel images are. And what I'm doing here in this for loop is I'm looping over it. So for every image in the raw images, what I'm doing first is to get the base name, which will return the file name to me. So what the base name will do is it will give me all these long file names as a list, and then not as a list. So for each of them, the base name will be just this file name. And what I want to do here is I'm saying that the wanted part is os dot file name dot split, and then from the last bar 3 to the last. So basically what I'm saying here is that I want to split it on the underscore and take L2A B1 raw.tif, and then also for all the other files respectively. And then the new name here will be, after getting these 3 items, I want to join them also by an underscore. So for instance, if I'm taking the band 1 as an example, the output will be, the output of this part, which is also here, this was just to explain it further, will be something like a list containing L2A, and then that is B01, I guess. And then I think it's raw.tif, something like that. Let's just assume that what I've typed here is correct. So this will give me, this line will give me something like this. And then now I want to join them all 3 by an underscore, so that will produce something like L2A. Oh, sorry. L2A underscore B01 underscore raw.tiff. So this line will take, or this place, the joining will take something like this, and they'll make it something like this. Okay. And then this last line is to rename it. So basically, take the image, give it a new name. So what it will do is that it will move it from the old place to the new place, and as it moves it, it renames it. Okay, so that line was not needed. So what I'll do is to run this. Did not get any error. So when I come back, I will see that my browser images is empty. It's only this file in here. It is not a TIFF file. All the data that we need is inside here, and they have been renamed. Of course, this true color, I don't need it anymore. Can safely delete it, and I'll also delete this browser images. But what I'll do is I will not delete this. I will comment them out. Maybe let me put a label here, renaming images, so that in case you get a code from GitHub and you are interested in doing that, you do it. but I'll comment all of it out. So you just uncomment it and then you can use it as well. Now let's go ahead and then read the bands. So now that we have the images in there, what we have to do is to read the bands. And so we need to get the images. So images, that should be equal to globe. And then we want to get os.path.join. We want to get data directory and then all the files in there. Sorry for these pop-ups. All the files in there that end with TIFF. Not data directory. So if we print out images, it is not very useful in the output, so we can say for I in images, then we want to print I, then we get all the images, so but we have the full part, which is of course what we are looking out for, so that is fine. But we can see that these images are not really sorted in a way that we want them to be. And so for instance, band 1 is down here, but I prefer that it starts from band 1 to band 11 in that order. So what I'll do is to keep these images there. Another variable, maybe not needed, maybe needed. I could have nested it on the other one, but it's okay. Let me keep it this way. And then I go sorted images. So if I go for I in band images rather, and then I print I, okay, band images, then I print I, this is sorted, but we have a little problem here. The band 8A, which was supposed to come immediately after the band 8, is now at the bottom. And that really doesn't really bring any problem, because what we are about to do next, we can map the band name, this band 1, to exactly what it is. You get to understand what I'm saying very soon. But if the order is also very important for you, I think it is, and it is, we have to make sure that this 8A follows the band 8, so that when we read, and we are performing analysis and we are calling the band, we are sure that we will not make a mistake by putting a wrong index for the band 8A. Well, this sorted function is not limited like that. It can do the work actually for us, but we have to extend it a bit. And it allows us also to pass a key to it. So what it is doing here is that it is sorting all the ones that look numeric, the numeric ones, cancel the numeric ones, and then this one that has an alphabet, it tries to bring it last. We can pass what you call a key. This place I might type code that is a little bit advanced. If you are okay with lambda functions, that is fine. But if not, don't worry, I will even explain everything line by line so we don't have a problem. We pass in a lambda function here, which is just an anonymous function. It doesn't have a name. It runs just in line, and then that is it. We want to get an integer of, and that is why I imported the regular expressions at the top. I'll explain the line, don't worry. re.find all, and this is the pattern we want to find. So r, and then b, and then backslash, this pop-up, backslash d plus for every x that is coming in. And then when you get it like this, also give us the first item. Don't worry, I will explain it very soon what each of them is doing. If, okay, so let me explain this one before I even proceed. What is this thing doing? So lambda x, so the lambda is an anonymous function, as I said. So this is the argument, and to the right side of the colon is the expression. So this argument here, x, is referring to the images, individual instances of the images that is coming in. Just like this for loop variable I refers to every I, or every item of the band images that is coming in. This x also acts like the same thing. So what it means is that we are passing in something, which in our case is x. So this one, because it's being worked on the band images, this x here is directly the band image here. So what we are doing is we are passing it in, and for each of them we want to carry out this operation on it. That is it. And now to this regular expression. So re.find all. What we are telling, look at the file names down here. What we are saying is that we have some strings that we are coming to pass to it, which of course is coming in through the band images, or this one, the images. So okay, so sorry, this x is the images, so not the band images, sorry, they are the images. So this x is the images, and this lambda x, this argument, is referring to the instances of the images that are coming in. So what this means is that you find a string, we are telling Python that it will find a string that looks like this. It will have an uppercase B, and then it will be followed by some integers, as I'm highlighting. So this D is stand for integers, 1 or 2 integers, and then this is this the for this is the this slash, whether it is forward or backward, I'm a bit confused about it right now, is that we use it to escape. So there are some characters in Python that we call them special characters. So if we then tell Python that this is not a special character, it may treat it as such. So we use these things to escape and let Python know that it's not anything special. We are just trying to define the pattern here. And so I think I've explained this one. So what it means is that for each instance of the x that is coming in, look for a pattern that looks like this, with a B that has some numbers after it. So B01 like this. And then if there is something like that inside, return it to us. If it still doesn't make so much sense to you, let me come to the top here and generate a code cell. And what I want to do is to copy this block, and then I'll put it inside a print statement. And instead of the x, what I'll do is to copy this name, not copy cell output. Let me just type it. So that is L to A underscore B01, also underscore, then I have row dot tif. I think that is it. Yes. So this name, the first part of it is not really necessary. All this place doesn't have any B or anything like that. The most interesting part is, is this ending, which is the actual file name. So if I run this cell, you see that it returns 01. So that is what we are telling it to do here in the expression. That's extract any string that looks like this, that is inside the string that we are passing to you. So this is the string we are passing to you, or in this case, the long file name with this uninteresting part. So extract the part that looks like this for us and return it. You may be wondering why I'm adding the 0 here, and I'm sure you have found out now. This in itself is returning this list. So if there are multiple items that match this, it will return them all. So if I say return the first element like this, it will just give me the 01 without it being in a list. And that is what I want, because I need it to convert to an integer. Remember, I'm converting this to an integer. And of course, if I print the type here, you see that it's a class of string, but I don't want to use the string to do the sorting. I want to sort it with integers. That is why I am converting this output also to an integer. So that is all that this line is doing. I hope you have understood it. If you still don't understand it, leave the comments and then let me know where your confusion is. Then I'll clarify it for you. Well, this looked promising, and for the files we have here, I don't think we will have any error, but it is always good to write safe code. So what if there is no pattern like this? Like in the, let's say you did not delete your true color file. What if that one is not there? Then it means that it will throw an error because it will not find a match. So I will say if, so do this if, and then I can basically copy this and paste. If this, so return this if there is a match. Else, you know, we are returning integers from there, so we can just now return any random number. Else return 99. That's all. And also, because we want to return all of these as let's say a tuple or an array, so I'll wrap from the end to the end all of it also in brackets like that, and I have to bring this comma here. I know this line is a lot, but if you still don't understand it, you can let me know. Okay, so now when I run this, you see that 8 and 8a, they are at the right place. So now we can safely refer to the bands using their indexes and will not be wrong. All right, so now let's proceed to read the bands. For that, I will define a function to help me read the bands. So we'll define read bands. It will take in the paths, and here I will write an empty list to store the band, the arrays, and say for path in paths. What I want to do here is with real.open, I want to open the path as src, and then after opening it as src, what I want to do is say bands.append, and then I'll append src dot read one, which also means that read the first band. But in this case where we are working with single band rasters, this is not necessarily required, but it's good code to put it there. And then after we read all of them, what we want to do is to return the bands. So this function is capable of taking all the images, the file names at once and reading them and returning them. And let me copy and paste this one from my notes. The goal is not for you to watch me type. All that I'm pasting here from my notes is this band names for the Sentinel-2. So the band 1, each of them with their names, because I like it this way. It makes it easier for me to call a particular band. For instance, if I want to call red, I don't have to memorize to know that red is band 4. I can just say band.red or something like that. So you can pause this part and type, or if you have the code from GitHub, you can just copy also and paste. So now we have to read the bands. What I can do is to say bands as a dictionary. So I can store them as key value pairs, and then we can map over these band names and the actual band arrays that we can read also with our function above. So that would be so simple for key or key value. You can also say band and then band array. Any descriptive name is okay. In zip of band names, I think it's band names, and then read underscore bands. We pass in the band images. Okay, I also saw something like bands images. This is band images. Yes. For this, we want to say that every band or the bands dictionary we have there for each of the keys assign that particular value. And so with this, we can now just say print bands, and you see that we have coastal aerosol and its array, and the others are truncated, of course, because they are long, but they are all there. So we can just now call it simply by saying print bands and then pass in here red, and then it will get red array. I think it should be able to work with this also. Okay, it doesn't work like this, but at least we can call it with a key like we did before. But if you even want to make this more optimized, a little bit advanced, you can use what we call dictionary comprehension. And in the same way, you can convert this all into one line. So that is what I'll use. I will keep also this code commented in case this is what you understand better. It is fine completely, but comprehensions are faster and optimized than this normal loop. So key value for every key comma value in zip of band names, and then read underscore bands. We pass in the band images, and we can also print bands, and then it will work just like it did before. For very small use cases like this, you may not really see the difference. It may not be significant, but as long as you can use comprehensions, they are far better than loops. Now that we have all our bands, what we have to do is to get to the actual thing for today, to compute the indices. So the first one we will do is NDWI. And for that, we will come to references here, documentation. Let's go to the Sentinel Hub. The link will take you to this page. So if you come to remote sensing indices here, you see there are lots of them. We are looking for NDWI. And there's the Sentinel-2 formula. They even have formula for other sensors, and that is fine. So what you are looking for is this Sentinel-2 formula. And this is just the formula we have to translate into code. So let's come. We need a band 3, which is the green band, and the band 8, which is the near infrared. So we can come here and say green, comma, NIR. That should be equal to bands, and then we want to get the green, and again bands, and we want to get a near infrared. All right. So we can also say now that NDWI equal to, like the formula we saw there, green minus NIR, then we divide it by green plus NIR. And that is it. We have computed the NDWI. As a matter of fact, if we can visualize this. So if I come here and then say from rasterio.plot, we want to import show, is a function there. I usually import it as rshow. I don't know why, but I like to import it this way. And now we can say rshow, and then we pass in NDWI. You can see here that this is the NDWI. You can pass some color marks to this. So I'll choose gray. And this is our NDWI. But if you look carefully, this axis here is not in UTM. This is not a raster file we are looking at. It's just a NumPy array of, if we actually print the type of NDWI, you see that it's just a NumPy array. So we have to save it, then we can now use it as a raster, bring it into any processing software like QGIS, and then continue any further analysis that we want to do as well. With that, what I want to do is to say an NDWI, maybe file. This is the place where, or the file name of the file that should be saved. So I can say output directory dot join path, and I want to join path with ndwi.tiff. So I want to save the file in the output directory, and this should be the name. And this is how we save files with rasterio. We will need the what we call the metadata from an existing raster, or if you know it, you can also write it there directly. But in this case, because we already have those properties, they will not change from the bands themselves. We can just copy and use those same properties to save the new file. So we can just say with real.open, and I think we call them band images. For this one, we can just read the first one. We don't care whichever one it is. And we read it as src. The metadata that we are looking for can be accessed with src.meta. So if I print meta, by the way, I'm using Control Command to run the cell. I should have stated it earlier in the video, sorry. Or you can click this execute cell here. If you're following this video, I just assume that you already know how to run a Jupyter cell. Sorry if you don't. And this is what we are looking for. Maybe we can print it in a more nicer way. So that will be for I, j in meta.items. We can just say print, and then in an F string, this will be I, j, and then we see that this is the driver. We take the driver, the type, and all these ones like that. If we want to now save the image, we open another wait block and then say real.open, and then we pass in the file path, which is now NDWI file, and this one we have to specify that we want to write the file. and you mostly see that it is opened as DST. You can open it as any other descriptive name, but this is also not bad in itself. And we can say dst.write. We want to write NDWI to the first as the first band. Let me say so. So if we're saving multi-band rasters, we'd have specified the index of each of them separately. Also, I forgot a very important step. That is, this method, we have to attach it to the raster we are saving. So there are two ways. The first one is to explicitly say width equal to meta width, height equal to meta.height or something like that. But Python also gives us a very easy way out. We can spread the data from this side, this metadata, directly into it without typing them explicitly one after the other. So when we do this, it will write it for us. But what I also want to do, it's not really compulsory, but I think it is good practice, is to set band description. And when we go into QGIS, I'll show you what the band description is. So I set band description for band 1, and then that is, I'll say Sentinel 2 NDWI. This, of course, I've made it simple. If you have any longer or more better description, you can give it here. So I can run this. Of course, you see my output folder where it is. It's empty for now, but as soon as I run this cell, I have an NDWI.tif inside it. And so when I come to QGIS, and I bring it in, this is our NDWI, and you can see the band description here, Sentinel-2 NDWI. All right. So let's go. You can change the symbology using any and apply any color that you like. Let's go and then look out for NDVI. Also, you can come to this index database and you can search for it here, or you can choose the index for a selected sensor. If I choose, for instance, see there are many sensors here. If I choose, for instance, Sentinel-2A, and I go to display indices, I have all these indices here. And depending on what or which one I want to calculate, I just translate the formula here to code, and then I'll be able to calculate it. But I'll prefer this one because it's simpler. And for the NDWI, we need the band 8, band 4, which is near infrared and red. So let's come back. What I'll do is to copy this code, and then I'll repeat it for the NDVI. Not so much will change. So, but at the top, let me give a markdown of NDVI. And that one I need the red instead of the green, so I'll change this. And if you're wondering how I was able to select the two and rename them at the same time, I'm using Control D. If you're on a Mac, that should be Command D. So in the same way, anything here that is NDWI, I want to change it to NDVI. And the band description itself to be Sentinel-2 NDVI. Okay, so this formula will of course change. So if you look at it, it is the near infrared minus red, red, and near infrared plus red. Okay, so fingers crossed. Hope we have done everything well. We can just run this and we should have it also in our file. It is there. We come to QGIS and we have our Sentinel-2 NDVI also there. Okay, so I think these are the two we will do. You already have this documentation here. You can go ahead and try your hands on all of the rest and all the ones you need. So that, my friends, is how we compute spectral indices in Python. I hope you found this tutorial useful. If so, please hit the like button and share this video to your friends who you think might also need it or like it. And if you don't understand anything, please leave comments and I'll do my best to respond to it as early as I can. Thank you so much once again for staying up to this time, and until next time, it is goodbye.